possible. Keep it simple, real-time, and read-write. Most people would say you could do one or two of those three things at the same time. We're trying to do all three. And build amazing experiences on top. And at the end of the day, it's the experiences that pay the bills. That's what we're really after. The infrastructure is a means to an end. But it's a means that we're going to try to make available to everybody else who's trying to achieve the same goals. We feel like we're all sort of working on the same things, and to the extent you can use us, we want you to. So let's talk about mapping everything. Now, with this crowd, I probably don't need to go into too many details about how to spatialize things, but let me try and go quickly through some of this. How do you map everything? Well, I have a two-step process. For each thing in everything, add a transform. For each user's view, fetch and draw the things that are most relevant. That's pretty much it when it comes down to it. There's a lot in those two statements, but we'll get into that in a second. What are things in this case? The things that we care about most right now are photos, panoramas. Spin movies are sort of inverse panoramas that go around and after. And you can see the whole list, leading to places, sentiments, markers, and tags. This is generally the set of user-created content that we care about. It doesn't mean that we need to stop there, but we're going to focus on that and try to make everything work there, and then see how things go from there. So you notice I mentioned transforms versus location. We always talk about location, but what it really matters is about getting the transformation right to where these objects are. So let's talk about why. Indoor needs local coordinates. All right, you're not going to have GPS indoors. There are other technologies which may be available, but nothing too good yet. So GPS is not useful to you. But you also have to deal with not just location, but we have rotation, you have scale. Photos and panoramas often don't even have a location indoors, even sometimes outdoors, depending on the technology used. So the transforms can be entirely relative. They can be just a graph connecting these things together. If you think about photosynthesis is a good example of that, navigating between the graph without necessarily having coordinates. For AR, you're going to want to include orientation, scale, field of view, and don't forget time. Time has to be built in from the ground up. It's a critical element. But even for simple 2D location, when you deal with a system that has user-created content in it, you have to deal with multiple assertions about facts, multiple coordinate systems. Mercator is not the only one we have to deal with, and multiple levels of precision, depending on what you're doing. Sometimes level of detail, but sometimes some devices will give you accurate information, some devices will give you very inaccurate information. These are all things you can deal with. So ask yourself, where is my office chair? I'm going to give you the answer for me. This is sort of a real-world example to think about the local coordinate system issue. Start with the typical addressing. Well, that's not very precise. It's accurate, certainly, but it's not very precise. What we need to know there is what's the latitude and longitude, maybe the altitude, but what's the precision of those numbers, so we have some guess. But then we need to find the office within the building, and so here's the local offset, sort of as the crow flies, if crows could fly through walls. And then we have the chair, which is within the office, and it needs a position and a rotation. So you can see just for something as simple as specifying an object in an office, you need at least 3 levels of hierarchy in this case. And it's something that needs to be built into the system. Okay, so also ask yourself, where is the Statue of Liberty? That's a good question. I'd say New York Harbor, having grown up in New York. I'll give you a latitude, longitude. I'll give you some photos. We can say it's a centroid, or which Statue of Liberty? And that's actually, D is probably the best question to ask as an answer, because there's more than one. And it turns out that, as I said before, accuracy does not equal precision. This is sort of an old concept, and it's very important to keep in mind, because B is actually in Seattle. And it could just be a Statue of Liberty sitting on my desk. With somebody, let's say somebody labeled as the Statue of Liberty, and we couldn't tell that it wasn't the real one in New York. And the picture is from Japan. I've never seen that personally. I have to trust somebody took a picture of it and told me that's in Japan. Okay, no, I don't doubt it. I'm just saying that the system is not going to know. Right, so the system is going to have multiple assertions. And we can't directly measure these facts. We need to have personalized views on the data, which are going to include different data for different people. And then there's this whole filter bubble that Jared alluded to this morning that we have to deal with. We don't want to have everybody live in their own isolated universes, but we don't want to show everybody everything at the same time either. There's just too much stuff. So in the end, the same authoritative answer does not work for everyone all the time. That's really the point of this. So this is all something of a challenge so far. We have to discover and glue together a lot of information. We have to allow people to synchronously edit the metadata at the very least, if not the actual underlying data, if we can. We have to stream only the information people want and need, and we have to build it incrementally. The cold start problem is an old problem that a lot of you are probably familiar with. No one is going to use your system until everyone else is using your system. We have to start with the data we have. We have to get it up and running. And we have to make it usable from day one and interesting from day one so that it will scale, that more people will show up and do more things. So the question is how. And when we thought about this and tried to figure out how we wanted to do this, we, very similar to what other people are thinking about here, it's not necessarily original thinking, thought, let's look at the web. Let's see how that works. And so for inspiration, we think of this off-cited William Gibson quote, and I'll give you my slightly different take on it, which is maybe not as pithy, but more appropriate for this talk. And the thing about the web is it is not very organized. There are some basic standards on which things are built, but a lot of it is chaotic, a lot of it is open and evolving all the time. So what we're saying is we're going to make our data available just like any other web data. We're going to make it easy to access. We're going to encourage you to do the same. Certainly we understand if you don't for whatever business reasons. But we're going to try to make it easy for you and make it worth your while. So if you put your data out there, we're talking about essentially creating a real-world web, the equivalent of the World Wide Web for real things, and talking about the way these things interlink together and getting a lot of the same benefits of the web. So one of those is anyone can link to anything. The same intellectual property rules still apply, copyright, copyleft, fair use. They still apply to data that's put out this way. But there's no single standard. So I'm actually hearing standards talk saying we don't need a single standard. Several are okay. And at this point in time, we may do better actually with something which is more of an open sandbox. It allows us to at least build the applications we want to build, not reinvent the wheel every single time, share data, and evolve towards something when then we can finally agree what actually needs to be codified. At least that's my premise so far. You may feel different. So how about connecting it? That's one of the most important features of the web, is how things interconnect. So let's talk about the interesting ways those things interconnect. I lost the projector. Okay. So RML stands for Reality Markup Language. It's just a slightly more elaborate wrapper around UI. There's no fixed schema or taxonomy. We have an initial stab at it, but we're happy to evolve it and change it as it needs to be. And in fact, we're going to leave it open for people to add their own JavaScript in it, and we'll store it. If you want to add new fields, we will just store those fields in our database, and you do whatever you need to do with those. It's mostly metadata. And when I say mostly, the stuff that's not is basically the content that we're putting out also. And it's in JSON now. We'll have an XML version soon. The key thing to understand is that we don't need to change or replace anyone's format or ingest their data. We just need the URLs and metadata. So we might extract out of some KML file the author, the date, the location. We might store those things so that we can connect it up better. But we don't need to make the equivalent of KML. We don't need to recreate that. And there's no point in doing so. It's already a standard. I used to work for Keyhole before it was part of Google, so I also support that. We need to focus on the parts that are missing, which is really this glue wrapper. The most important thing is to keep it extensible, real-time, and read-write. That's one of the hardest things to do, but we have to get that right, or else it's just not going to be useful. So how do we connect entities beyond the usual map coordinates? Well, for each thing, we add a list of relations. So we don't just have one kind of relationship, which is links to, but we have matches. When images are similar visually and in proximity, we can create a match relationship. And at the end of this, based on how much time I have left, I will do a demo. Instance of hierarchy is interesting. Instance of is one where we want to be able to say there are multiple statues of liberty. They all reference some common entity, which stores a lot of interesting information about that, maybe reviews about a product in some cases, other annotations. And there's a connection back and forth between the instances and the canonical version. How do we respect IP without using DRM? I'm strongly opposed to DRM myself. I'm not speaking for the company. For each thing and everything, add an information nugget. And this goes back to, if you think about Jaren's talk this morning about the old concepts of Ted Nelson. In this case, what we're saying is, yeah, things probably should exist only once. They may not be on one server. But we want to remember who created what. The license information, the authorship information, in fact, if we can create a chain of authorship, when people take things and mash them up, we'll be able to do some very, very interesting things down the road. The license information, for now, is just enough to be able to say where something came from and what rights do we have. Do we have the right to edit it? Do we have the right to display it even, perhaps? In some contexts, it wouldn't be allowed. And it's up to the owner of the data to decide what license they want. We're going to encourage Creative Commons for everything. But we can't force it. It's up to you. It's your data, so you decide. And unlike other companies, we're going to say you own your data. Just because you put your data in the system doesn't mean we retain rights to that. Okay. And in fact, for the actual metadata that we're serving, we're going to try to make that as open as possible. It's not definitive yet what the license will be, but we're going to push for the most open. All right. Keep it simple, real time, and rewrite. We move a little faster. So here's the gratuitous color diagram. I had to have at least one diagram in this. So I'm going to go very quickly. You got an RML viewer that's just JavaScript running in a standard browser. Doesn't need to be anything special. We're going to open source the JavaScript so you can take it and do what you want with it. Connect up to the RML API, send data back and forth, communicate with the database. User agents, I'm going very quickly here. User agents will go out to the web, very much like what Blair talked about, and fetch other data that's needed. We will try to reflect whatever we find from other sites, Twitter, Facebook, etc., back into the database, only as much as we have license to. So we may not copy all of it. We may just copy the metadata only, and serve that back to the client. But that's certainly not the only data we have to deal with. There's things like image files, which are going to be stored on a content distribution network. They're not going to be stored in RML per se. They're images. They're binary data. So the client will just go directly to those. The RML points the way. The RML contains the URL of the information. The client now knows where it is and goes and fetches it directly. And then that gets around all the connection limits that you might have. So we don't want a client connecting to the server 50,000 times. Now, things don't have to live in Azure. The URL can point anywhere. The URL can point to any content distribution network, any website that hosts the data. There's no limitation on that. And in fact, we don't even have to know what kind of a service it is. It could be any data service. And the RML could potentially even include JavaScript, which would tell you how to access the data, how to manipulate that. And we have some technology that will allow sandboxing of JavaScript, so we can potentially make that safe. But that's to be decided. Finally, I missed one thing. And there's also the write aspect, so clients can write. I just subtly changed the line there to white. So changes you make go back into the database in real time and are available to anybody else who happens to be looking at that same place, the same part of the world at the same time. They're essentially subscribed to that data. And of course, there can be other clients and services that call our API. If you have your own AR browser, there's no problem with you calling our API. You don't have to use a standard web browser if you don't want to. You can use the JavaScript that we write to access our APIs, or you can go directly to the APIs. It's really not fun. Okay. And then, of course, the final thing is there's workers that sit there and live in the cloud. The ones that we write will live in Azure, and they will take the database and try to improve it. An example of improving it would be the matching service. So as people submit images, we want to go in and actually find correspondences between those images. We're not going to do that necessarily in real time, but it's pretty fast. But that improves the RML, that creates connections that didn't exist before. And some of those things will take time, and kind of like uploading a video to YouTube, it may take a little while, and then you get a notice back saying, we just found 20 connections. We found all these things. And in some cases, it only takes a few seconds. But we're not going to make you wait. All right, what does it look like? So you're asking questions about the actual form of this thing. These are the 4 bullet points that I had from before. I'm just repeating those things, and I'm showing you that that's pretty much what the JSON looks like. It's almost exactly what I said before. You have to add transformation. You want to know what the sources are that you can fetch directly. You want to store the relationships. You want to store the information of it. At a very superficial level, that's kind of what it looks like. And it is likely to change. And on the very last slide, I'll actually give you an opportunity to help change it. The APIs, we're also trying to keep very simple. RESTful APIs, where you can just say, give me an entity, here's the changes for an entity, we'll just take them, we'll just put them back. Streaming is another option. I missed the search option, so we can RESTfully call, give me everything within a bounding box, subject to relevance. You might only ask for 100 items. Hopefully we'll give you the 100 most. We can do time searching, so you can give it within a temporal bounding box. Filter sets, detail, pivot. You can imagine, since we have multiple graphs, we're not just going to have spatial relationships. You can imagine saying, find me everything here, but traverse the social graph that we ingest from Facebook and find things that the friends of people here also like, and collect those up together in the same search. This should all be fairly simple to do. The streaming APIs are equivalent, but the idea there is for clients that repeatedly call our services over and over again, we're asking you to create a connection, and we'll keep stuffing new things down the same connection rather than have you poll us every second. It'll be more efficient. We can do some optimization on the server side. Okay, build amazing experiences on top. Last step. I mentioned that this is works in standard browsers. We're talking about JavaScript implementation, JSON XML, HTML for the display. Nothing too custom there. This may be interesting to some people who like WebGL. I personally, Susan herself, think that that's the way 3D will happen on the web. It's really just waiting on certain companies to fix their drivers. What it comes down to it is fix your damn drivers, and WebGL will be out there tomorrow. I put a little asterisk there because I know someone will ask me a question related to WebGL support at Microsoft, and I will not answer that today. So, sorry. I'm going to avoid that question, but I'm going to say from the perspective of Bing, we're going to use it, and we're going to encourage the rest of the company to also use it. That's our position. So how about the camera? A lot of you are doing much more complicated things that won't run in JavaScript, that you need native code. So in those cases, what I would encourage you to do is either call the services directly or embed the JavaScript. If you want to embed a WebKit browser in your native app on a phone, do so and run the native bits as you need to. But it's up to you how you want to do it. Okay, so we're going to summarize. Microsoft provides services. We'll open simple APIs. We'll let you add and edit most RML in real time. We'll incrementally expose our data via RML. That's what Blaze talked about this morning. So it's a big project for us just to take all of our data and make it available in this format and make it easy to use. We'll offer free open source JavaScript viewers to match up that you can take. We'll encourage you to link your data to ours in a way where the URLs are permanent and static. And we'll also try to link our data to yours to the extent that you make it available in the same way. We're encouraging you to do something. It's just like the web. That's really the philosophy here. And I think that really is the way forward rather than trying to create new standards. I think the ones that are out there are going to serve us well, just like Blair said exactly the same thing. So here's how you can contact us. Me, there's my email address, which is very strange spelling of my name. We are hiring, if you're interested. And one more invitation that I'll give you today, just lost the mention again, is for those of you who are interested and who want to come to Seattle, sometime in probably around the second week of July, although we're flexible, we're going to basically do the equivalent of the camp thing. So we'll come and get together for 2 days maybe. Anyone who wants to give input to this, who wants to use it hands-on, who wants to help drive the direction of this, we're happy to have you. I've already talked to some people informally, and there's some interest. So just email me, and we'll all arrange it, right? So now the demo. Okay, so I have to warn you that this demo will not be visually impressive as all of the AR demos that you've seen. I'm not going to even call this AR at the moment. Sorry. Always close your Outlook before you do a demo. So I'm running 2 instances of our browser. This is actually an editor browser, and it is pulling RML from our service. It's running live. This is a throwaway URL, but it's going to work today. And one of the things I wanted to show you is, let me start this over so they both have the same point of view, so you see the same photos. So if I come over here and grab a photograph, I want you to see that I'm moving it on the right, and it's updating on the left immediately. That's the latency that we have at the moment for making changes in rewrite world. A few, tens, 100 millisecond maybe. And that'll only get better. So this should scale. We're in the process of testing it right now. What you're seeing there, I'll show you a little bit of the code. If I scroll down, there's the actual raw RML in a slightly older form than I showed today. That is just pointing to a bunch of resolutions of Flickr images. Very straightforward. So let me just close one of these 2 instances. This will work obviously on any number of computers at the same time. So here we're just going to scroll around. Thanks especially to Chaz for making this possible by giving me another network to try this on. I'm just going to scroll around. What you're seeing here is real-time relevance filtering. So the information coming back from the server, as we move around, the POV is getting sent up to the server, and the stream that I've talked about before, only the new objects that you need to see are getting sent down. We're not repeating any information. And what we're seeing, some interesting information come down. But one last thing I'm going to show you before I go is this matching service, which is integrated into this. So if I come over to a particular photo, let's say Pike Place Market. We always use that for demos. Here's a good one. If I right-click on this, a little wait animation while it's going out to the matching service. I'll do a couple of these. It is going and finding matches, and now it's showing me the matches. So this one finished already. So it's essentially saying this image, the ones it's linking to, like this one down here, are visual matches. This is the first step. You can imagine it's a technology that allows you to upload a photograph where there's a dense set of photographs that we already have and find out exactly where that graph is without precise GPS orientation, simply from visual realm alone. So we're showing that working. And that part of the service is actually live today. So you can play with that. If you go to readwriteroll.net, you can play with just the matching portion. We'll roll out the rest of it shortly. So that's my talk. Thanks for your time. And let's go.
Hi. What are you using for storage on the back end?
That's a great question. This is all running in Azure. We are using a lot of the existing Microsoft technologies, but we're also augmenting that with some third-party vendors that, if we'd had agreements where where we got a discount for free advertising, I'd tell you who they are. But I'm not going to mention it. But I will say this: it's very fond of. Huh?
Because that's fast.
Yeah, it is. It's actually extremely fast. It's also a NoSQL database, so we're literally just storing the JSON objects that we have on the client are just getting sent to the server. The server just stores them as is and can index those JSON objects in real time. That's one of the beauties of NoSQL.